Now I'm going to have a look at what happens when we have a horizontal shift within a periodic graph. So the general form of the equation from y equals sine x becomes y equals a sine b of x plus c, and then of course plus d, where c is our horizontal shift. Obviously, if you've watched the previous video, you'll know that a is the amplitude, b affects the period, and d is the vertical shift. Now what's important here, to give us the horizontal shift, the coefficient of x has to be 1 within the brackets. And of course, if I wanted to do a horizontal shift including, from the graph y equals cos x, the general form of the equation becomes exactly the same, where a, b, c and d all stand for the same as the previous equation. So let's have a look at trying to sketch one of these graphs. Alright, so let's give this a go. Let's sketch the graph of y equals 2 sine bracket x plus pi upon 3. Now if we look at this, we can see that there is a shift from the sine graph, so we need to think about the key features of the sine graph. We look at the amplitude has changed. The amplitude is now 2. And of course there's no vertical shift because there's no plus d on the end. We do have 1 as the coefficient of x, so the period hasn't been changed because there's no value of, well, there is a value, the value of b is 1. So the 2 pi is still the period of this particular function. However, there's been a horizontal shift, which tells me that the graph has shifted pi upon 3 to the left. Remember, we go the opposite sign when it's in a bracket. So I've got to work out, well, and I have a domain as well, don't forget that I'm going from minus 2 pi to 2 pi. So I've got to think about sine graph and think about, well, where are those x-intercepts and how much have they changed? What are the new x-intercepts by moving them pi upon 3? So using the normal sine graph, if we remind ourselves just from 0 to 2 pi for a start, there's sine. The first x-intercept or the first key point is at pi, and the second one is at 2 pi. So we need to work out those shifted to the left. So I'm actually going to do pi, take away pi upon 3 to work out the first intercept. And then the second intercept, I'm going to work out 2 pi, subtract pi upon 3. So I need to work those out. So we keep the denominators the same. That will be 3 pi upon 3 minus 1 pi upon 3. Tells me that the new x-intercept here, shifted that way, will be 2 pi upon 3. And looking at this one, well, this one becomes 6 pi upon 3 minus pi upon 3. So remember, I'm looking to get the same denominator. And that tells me that the new intercept here is 5 pi upon 3. So those two have shifted. Now I then need to look at what does the normal sine graph look going back this way. Well, going back this way, the first intercept I come across is minus pi. And remember, it's shifted that way. So I need to then do, so that's the first one, the second one. Let's look at the third x-intercept. I'm going to do minus pi upon 3. So looking at that, that's minus 3 pi upon 3 minus another pi upon 3, tells me that that new x-intercept is going to be minus 4 pi upon 3. And similarly, this one would be normally minus 2 pi. I need to shift it that way. So my new position is going to be 2 pi, which is 6 pi upon 3, minus 6 pi upon 3, minus pi upon 3 tells me that's minus 7 pi upon 3, so that will be the new one. So when I sketch it, all I've got to do is change the amplitude so that it's no longer 1, it's now 2, and my sketch becomes, and of course it's easier if you do have squares, but you've got to still stick with the domain of minus 2 pi to 2 pi. So we start with minus 2 pi, and we literally shift each of these back. So we've got that 0, that position becomes 2 pi upon 3, that position becomes that's 2 pi upon 3, that one's 5 pi upon 3, that one becomes minus 4 pi upon 3, and that one becomes minus 7 pi upon 3, and then you've just got to get the shape right with the amplitude from 2 to minus 2, and so we go up there, down to there, and you do have to think about what it's going to look like. There we go, and then you just keep going for a little bit so it finishes at 2 pi, and then here we go down to there, into there, we have 1, there, back there, and you just keep going so you finish at minus 2 pi there, which is obviously where the domain is. And that is pretty much how you sketch graphs with a given domain.